Hello again, everyone. Welcome to another in our series, Statistics Made Easy. This is lesson 2 and it's on types of variables. In lesson 1, I concluded by saying that we're going to have in lesson 2 means, standard deviation, and variance. But I thought that we could have types of variables as a prelude to that. I am Peter Okebukola. What did we do in lesson 1? What we did was to collect data for a study on African students' views on the impact of COVID-19 on the educational system. After collecting the data, we then saved it in Excel for further analysis. Today, this lesson, we're going to have very exciting time looking at 5 things. One, we're going to scan the data that we collected, and then we're going to classify variables and then differentiate between population and sample, and also differentiate between inferential and descriptive statistics, and then identify that mean, standard deviation, and variance are major bridges, like Third Mainland Bridge, Eco Bridge, Marina Bridge, between, by the way, I'm naming bridges in Nigeria, between descriptive and inferential statistics. Before I go on, make sure that you remove your garment of fear of mathematics, or fear of statistics. Remove your garment, because here we're going to teach ourselves like babies. So let's begin with scanning the data that we collected. So here we are with the data. As you can see, entry number 1 in this row is blank. This other one is blank. This row 3 is also blank, and then this row 14 is blank. We'll be cleaning our data later, but what is interesting for us to see is that we have surname, first name. You can see that they're all varying. They are not the same. Nationality, we have Nigerian, Burundian. Institution, they're different. Specialization, different. Class of degree, different. Sex, different. Let's keep scrolling. So you can see we're scanning the data now though. You have sex, male, female, where you live. Some people are living urban and rural. Email addresses are different. How will you rate you can see the rating, let's see now. How will you rate your socioeconomic status, SES? You can see some claim to be average, some claim to be low, some claim to be high. And the score in discussion forum number 1, you can see the scores are also varying, and all of this varying. And the perception on student performance will be negatively affected by COVID-19. You can see everything here is varying. So our objective number 1 is done. And what's that objective? For us to scan our data. So while we were scanning the data, we saw variability. We saw they were varying. And that now brings us to variables. Varying variables. So what are the variables that we saw that were varying? We saw that sex was varying, male and female. Specialization, varying. Those with ICT, STEM education, law, science, all of that, varying. Location, also varying. Location will mean urban, rural. So these are variables. Any data that you collect that varies from one to the other, we say it's a variable. Now, mind how I pronounce that word. I said data. Some people call it data. It is not wrong. It's a matter of style, but I prefer to call it data. So for the rest of the class, I'll be talking about data collected from our class ACE 811911. So you can see these are variables. This is a variable, this is a variable, this is a variable, this is a variable, like we saw in our scan variables. Now, we can classify the variables. I'm going now to the third objective. We can classify, second objective. We can classify the variables. And one method of classification, there are several of them. One method of classification is to group them as quantitative and then categorical. So what are quantitative data or quantitative variables? Those are ones that you can perform arithmetic calculations on. For example, what are the examples? Can you give me some examples that you can calculate? You can, from the data, you can compute. You can divide, you can multiply, you can subtract, and all of those arithmetic operations. Yeah, I can hear some of you saying, scores on the quiz. You are very right. Scores on the discussion forum, you are very right. Now let's go back to our data to see. Yeah, so from here, you can see what did you score in the discussion forum 1? It's 5, 10, 10, 7. So 0, 10, 10. So these are scores that you can add, you can multiply, you can carry out arithmetic operations on. Also, let's look at quiz score on quiz 1. You can see overall score for that week. You can see 70, 98.2, 70. I figured that this person just joined the class and all of that. So you can see those variables that are quantitative. Can we look at another, the other type? That's categorical data, categorical variables. These are the ones you cannot perform arithmetic calculations on. They are, let's look at examples from our class data about categorical variables that you cannot perform arithmetic calculations on. Sex, you can't multiply, divide male or female. You can subtract male or female. Location, you can't subtract, you can't divide, you can't carry out any of these arithmetic operations on. But any of you in class, if you know you can, let us know. I'm sure nobody can. Socioeconomic status, high, average, low, you cannot compute anything. You cannot, you cannot add, subtract, divide, multiply. So these are categorical variables. When we come to data analysis towards the end, you find that you can actually transform this from average, low, low, average, high. You can keep them, turn them to quantitative. But for now, just know they are categorical, as you'll be able to see from our data. Let's get back to our data again. So as you can see, institution is categorical because either LASU, ACTC, University of Burundi, or other. So you cannot be multiplying this or dividing. The specialization is also categorical. So we cannot be multiplying or dividing or adding or subtracting all of this. Class of degree is also categorical. What about sex? Can I hear somebody in class tell me, oh yeah, you got it. Sex is also categorical. So these are examples of categorical variables. Again, we have the variables into quantitative that you can perform arithmetic operations on. Categorical that are in groups or categories. So let's look at this. What are the quantitative and categorical variables in our study? I've just extracted some of them here, data collected from our class. Now, let us turn all the quantitative variables to red. So what color will this be? Score discussion forum. Yes, somebody in class. Yeah, you're correct. You're correct. So this is red. What about sex? Let's use this color, dark blue. What color should we give to this? Is it categorical or variable or quantitative? Right, you're correct. So this is blue because it's categorical. What about specialization? We looked at them just now. Yes, blue. What about this? Location is categorical. What about score in quiz 1? Anybody? Oh yeah, all of you. I can hear you all say that it is quantitative, so it has to be red. What about attitude to science? These are the scores that you generated, so it has to also be red. Socioeconomic status, high, average, low. Did somebody say categorical? Yes, that person is right. So we have categorical. Nationality is also categorical. So let's see what our results are. So you can see all the blue ones here are categorical variables, and score on discussion forum, attitude to science, and score in quiz 1 are quantitative variables. Let's see more on variables. We have discrete variables and continuous variables. Let's look at discrete variables. Now, these are variables that can only be measured in certain numbers, e.g., number of buses in your university, or number of cars that you have, or number of dogs that you have. So you can have, for instance, okay, in Lagos State University, we have over 40 buses, maybe 50 or more buses. Now, these buses, you can say, Lagos State University, how many buses do you have? Oh, we have 4 1/4 buses. So you can only be measured in certain numbers. Or you say, how many children do you have? So it's discrete. You say, oh, I have 5.5 children. That's not all. So these are discrete variables. Now there are some we call continuous variables. Now this one can take any kind of numerical value, like the score on quiz number 1. It can be 1, it can be 2, it can be 3, it can be whatever. Let's look at that. Let's look at that data again. So we can see, for instance, score on quiz 1 can be 7, 6, 8. It can be 8.5, 9.5. Like the data the Moodle platform, a virtual learning environment platform generated were in decimal places. So here, overall quiz score, you can see 70, 98.2, you can see 76, 77.6, 50, 96.5, 45.1. So these are continuous variables. Again, to summarize, variables which you can classify: discrete, measured in certain numbers; continuous, take on any numerical value. Now let's go on to our third objective: population and sample. You will recall that our study is about seeking the perception of African students. So all of this, Africa, 54 countries, 55, 54 countries. Let's stick with 54 countries. And so that's the population. Every student in Africa has a chance. Has a chance of being surveyed. But I need, let's say now, maybe 20 billion naira to go and conduct this study all through Africa with you. We are going to go together. But unfortunately, we are locked down. We can't go nowhere. So we got to take part a subset of this population. And that's the sample. The sample, for instance, instead of 54 countries, now we have 1, 2, 3, 4. Just 4 countries. And in some countries, we have just a handful of students. So the idea is for us to draw a sample from the population. And the population means everybody in the group that we are targeting. And the sample is a subset of our population. As I said, remember our study is on African students' views on the impact of COVID-19 on the educational system. I can't go through all of them. So what we must do is to be like prophets. Prophet. What does a prophet do? We want to be able to infer from the data that we collected from our sample. We want to be able to draw inference for the entire population. Did you see the word infer? That brings us to to this concept of inferential statistics. Inferential statistics. We said sample. You are inferring, prophesying. What you have found could be true for the whole of Africa. Now, inferential statistics, by way of definition, are used to make predictions about a population based on a sample. To make predictions about the population, we're prophets now, about the whole of Africa based on a sample from that population. Dear students, ladies and gentlemen, all we are doing in this course is calculating sample statistics. All the statistics we'll be doing here, all the advanced statistics we'll be doing here will be on the sample to enable us to draw inference for the population. Look at the topics we'll be covering. T-test, ANOVA. We'll learn this in lesson 1. Look at all of this. These are inferential statistics because we'll be applying them on our sample to be able to infer for the population. We'll also be dealing with what we call descriptive statistics. Now, this, as the name implies, these are statistics for describing the population, either through numerical calculations or graphs or tables. Let me show you something. You can see from our study, responses 47. So you're able to see that, the first 2 cases, the first 2 rows blank and one in blue. So that gives us the 44 that we're talking about. You'll be able to see these graphs. That's descriptive statistics. Graphs, tables, These are graphs all the way through. Graphs. So let's see. You see, these are also graphs. What did you score? Okay, now I just put in the graphs of this. So these are descriptive statistics. So they are descriptive statistics because they give us graphs and we look at tables. Now there are different types of descriptive statistics. You have what we call measures of strength of frequency, percentage, and all that. Measures of central tendency, mean, median, and mode. Measures of dispersion of variation, variance, standard deviation. You can see I've highlighted this. I'll come to this too in a minute. Measures of position, percentile ranks, quartile ranks. Now, you must have learned this. You are masters and doctoral students. In your early days, you must have learned about descriptive statistics. So we're not going to delve much into this. We're going to assume that you know them. But for our purpose, we have identified 3 important bridges between the inferential and the descriptive. They connect the descriptive with the inferential. As PhD people, one will expect that if it is not wholly qualitative data, we'll expect that for your quantitative part, you use some statistics that befit. Let me just use that word for want of anything to say. Befit your status. So your status will mean that you should use inferential statistics that we listed here, ANOVA, t-test, all of this. This will make your work. It will help you to extract more meaningful findings from your data. So the mean, the standard deviation, and the variance are very important as bridges between descriptive and inferential. That is why we'll be taking them on in our next lesson. So what have we learned in this lesson? We have scanned the data that we collected, we classified the variables, we differentiated between population and sample, we differentiated between inferential and descriptive statistics, and we were able to identify that the mean, standard deviation, and variance are major bridges between descriptive and inferential studies. So in the next lesson, we shall be climbing this bridge. We shall be calculating the mean, standard deviation, and variance from our data. As I said, these are still very elementary things, but they are important for us when we are climbing towards going to the other side of the bridge between descriptive and inferential, when we're looking at t-test and ANOVA that Professor Tony Lusonya will be engaging you in over this weekend. So it is bye for now from me, Peter Okebukola. Again, that's my email ID, an event you want to make some contact with me. Bye bye, class. See you lesson.